Hi, I'm Thomas. Welcome back. Our topic is vectors. In this lesson, we'll learn to evaluate the intersection of two lines. In working with lines in three-dimensional space, there are three possibilities of relationship between the two lines. One is parallel lines, in which case the direction vectors of the lines are the same. In our example, the direction vectors are, in the first equation, 2i minus j plus 3k, and in the second equation, 2i plus j plus 4k. Those are different direction vectors, thus these are not parallel lines. The second possible relationship is skew lines. Skew lines are neither parallel nor intersecting. And the third possible relationship is intersecting lines. The algorithm we'll use for this example is the process we use to determine whether lines are skew or intersecting. Our problem reads, show that the lines with vector equations r equals quantity 3i plus 8j minus 2k plus t times quantity 2i minus j plus 3k and r equals quantity 7i plus 4j plus 3k plus s times quantity 2i plus j plus 4k intersect and find the position vector of their point of intersection. Let's go to the algorithm. Step 1, write equations in parametric form. Starting with the first equation, we identify our two x components. Those are the coefficients of I as 3 plus 2 times t. Next, y equals, now working with the coefficients of the j terms, 8 minus t, and z equals, now working with coefficients of the k terms, negative 2 plus 3t. For the second equation, x equals 7 plus 2s, y equals 4 plus s, and z equals 3 plus 4s. Step 2, equate components. The x from the first equation of 3 plus 2t will equate to the x from the second equation of 7 plus 2s. Same with the y's. 8 minus t equals 4 plus s. And for the z's, negative 2 plus 3t equals 3 plus 4s. Step 3, solve for parameter values. We'll work with two of our equations from step 2 and work with the remaining equation in step 4. Starting with the first equation in step 2, 3 plus 2t equals 7 plus 2s. I will manipulate to 2t equals 7 plus 2s minus 3. Dividing both sides by 2. We have t equals, in the numerator, 7 minus 3 is 4. 4 divided by 2 is 2. Plus 2s divided by 2 is s. With this value for t, we'll go to the second equation in step 2 and substitute in for t 2 plus s. 8 minus t becomes 8 minus 2 plus s equals 4 plus s. Notice that my t term is in parentheses. Since we're subtracting minus t, I want to distribute the minus to all terms representing t. 8 minus 2 minus s equals 4 plus s. 8 minus 2 on the left is 6. We'll subtract 4 from both sides. 8 minus 2 minus 4 is 2. Equals, we have negative s on the left. We'll add s to both sides. We end up with 2s, simplifying s equals 1. We can now solve for t by replacing s with 1 in either of the two equations that we selected to work with the first two equations in step 2. Notice the first step in step 3, I'm using the first equation from step 2. I've simplified that to t equals 2 plus s. So I'll take this equation and substitute for s 1. T equals 2 plus 1. I'm putting 1 into the first equation from step 2, which I've simplified in step 3. T equals 2 plus 1. T equals 3. On to step 4, check. Here's where we're going to identify whether these lines are in fact intersecting, as we're trying to prove, or are skew. Our check will involve the third equation in step 2. We're going to input the t and s values that we've calculated to see whether the equation is true. That third equation, where we've equated the z's, negative 2 plus 3t equals 3 plus 4s, we will set up as negative 2 plus 3 times the t value we calculated in step 3 of 3 equals 3 plus 4 times the s value we calculated in step 3, which is 1. On the left, negative 2 plus 9 is 7. On the right, 3 plus 4 times 1 is 7. We check and verify, because 7 equals 7, that these two lines do intersect. There's an additional step this particular problem requires. Before going on to that step, an observation regarding step 4 of the algorithm. If the result of the check ends up being untrue, then you have skew lines. So, for example, if in our step 4 we resulted in 7 equals 9, 7 doesn't equal 9, that would be an indication that the lines do not intersect, rather are skew. In this case, we have proven, as the check in step 4 does result in a true equality, that these lines intersect. Now our additional step is find the position vector of their point of intersection. Now to find a point of intersection, I can take either of my vector equations and set the equation in component form in a column matrix, working with the first vector equation, beginning with x values 3 plus 2t, then y values 8 minus t, then our z values negative 2 plus 3t. We've calculated a t value of 3, so when t equals 3, we end up with 3 plus 2 times 3 is 9, 8 minus 3 is 5, negative 2 plus 3 times 3 is 7. And the vector equation of the position vector of the intersection point is r equals 9i plus 5j plus 7k. We've completed our requirements, and this concludes the lesson on vectors and intersecting lines.